Hello and welcome to another episode of Math with Shinrai Sensei. And today we're going to be talking about scientific notation. Now, scientific notation is a very simple concept, but it's used for very large scales in science, really. But sometimes in math you encounter it. More often though in science. And scientific notation is when you use when you use 10 to a power to express how large a number can be, right? So 10 to the 23rd means that this decimal point needs to move 23 decimal points to the right, which would mean that it has 21 zeros behind that 3.01. All of a sudden there's going to be 21 zeros behind it, and that is the number of meters per second, right? So I could sit here and write 23, of the 23 out and be like 301, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19, 21. And that's how many meters per second that number is, right? So 10 to the 23rd is all of these numbers that used to be behind the decimal. Well, now the decimal's here. And that's really all scientific notation is. So, give you some shorthand examples real quick. Got to find the trusty fuzzy eraser here. There we go. All right. So let's give you some shorter examples, kind of give you a little bit better of an understanding here. Right? So if I was to write 5 times 10 to the 5th, then it'd be 5 with 5 zeros behind it, right? Which is 500,000. If it's 5.92 times 10 to the 9th, and it's 5, 9, 2, 1, 2, 3, 4, 5, 6, 7. There's only 7 zeros after that one because the 9, 2 get moved as well, and the decimal point goes to there. So this and this are equivalent. This and this are equivalent. 6.445 times 10 to the 3rd would be 6,445. Now, obviously, you're very rarely probably going to encounter a situation where such small numbers are going to be expressed in scientific notation as 500,000 or 5,920,000,000. They're really rarely going to be expressed in scientific notation. And it really is only in science, hence why it's called scientific notation. It's for expressing things like distances between stars and the speed of light and, the acceleration of objects towards the singularity of a black hole. Things like that are what we're going to use scientific notation for, because the numbers that you're dealing with, like the mole, right? Or, like I said previously, the speed of light. These numbers are so massive when you're writing them out in the unit that is standard. So for speed, meters per second is the standard. Even though at that scale, kilometers per second would be much more appropriate, the standard is meters per second, and so we use meters per second. And so you have to be able to write that in a way that's not going to take up entire textbooks writing out that number, right? So if I was to write out the number of particles there are in the universe theoretically, the number would be so massive. If I was to never include a decimal point in it, the number would be so massive that I could fill up entire libraries with just zeros, right? With just the zeros that come after the approximate number of particles, I could fill up entire libraries with books just filled with zeros, right? So that's really what the scientific notation is for these huge numbers. This is just simple examples to kind of give you an idea and an understanding of what exactly we're talking about with scientific notation. And I know this is kind of unusual to touch on science topics when we're doing a math episode, but obviously this is math as well, and math is pretty much the most common thing in the universe as far as our understanding of things goes. There's always numbers that quantify something to do with the universe. And so scientific notation just helps us to write in a much shorter and more manageable fashion massive numbers that have huge, numbers of decimal points that are just zero behind them often, not always, but often. The number will not have very many things after the decimal. The number will have like maybe 2 or 3 digits after the decimal. And so what you're really going to be having, that 10 power is usually going to be a large number of zeros. But like I said, that's often, not always, right? That's a huge distinction that you need to be able to make in both math and science as well. There's a difference between always and often, and that's something that we'll probably touch on in some English episodes in the future, is like making sure you understand that words have meaning. And if you misuse words, or if you try to turn the meaning around, it can mess up every single thing to do with that word. But that's not really relevant for today. The topic today, scientific notation. Like I said, pretty simple examples. Just shows you that the decimal point moves 9 places. Or in this case, it moves 5 places. Or in this case, it moves 3 places and turns those numbers into that. Right? So if you guys have any questions, please leave them in the comment section below. And if you want me to cover any topic specifically, once again, please leave them in the comment section below. And I will look forward to seeing you guys in the next one.